So hello everyone. Today we are solving number of people aware of secret. On day one person discovers a secret. You are given integer delay, which means each person will share the secret with new person every day, starting from delay days after discovering the secret. You are also given an integer forget, which means that each person will forget the secret after forget days after they discover the secret. It means after let's suppose they will have discovered the secret on day X, right? So he can spread secret after X plus delay days and can spread up to the day becomes day plus forget. So between day plus delay to day plus forget, the particular person can what spread the message, the secret. You are given an integer n. Return the number of people who know the secret at the end of day n. Since the number can be very large, you have to return the value by doing modulo with this particular number. So as n is equal to 6, delay is equal to 2 and forget is equal to 4. So we are given the solution. You can think, as I said, at day 1 only one person will remember, only one person knows this secret. After 1 plus delay, whatever the day comes, on that particular day he starts to spread secret, and he can continue to spread secret until I plus forget day arrives. Means 1 plus forget day, then person 1 will continue to spread the secret, right? So what we are going to do is we are going to maintain a vector. Let I have named it here as knows, right? And the variable answer. On the day 1, the first ones on the day 1 only one person knows the secret, so I am going to assign the no 1 is equal to 1. At day 1 only one person knows the secret, so I am going for all days, day is equal to 1 to day is equal to n, right? And as I mentioned, we are going to check until the ith person will spread the secret till I plus delay to I plus forgot or forget, whatever it is. So at jth day, the person knows the secret is the current at current day whatever people knows, and the ith day the people who know, we are going to sum it up their values. Since we are in the given problem, we are given n is equal to 6 and day is equal to 2 and forget is equal to 4, right? So from day 2 to day 4, the person 1 can spread the secret, right? As they have mentioned, day 1, suppose the first person he knows the secret and he can start spreading the secret at I plus 2, which is 3. From third day he can start to spread the secret. So at day 3, as we can see, initially 0 people know at day 3, plus the ith, the first person, we are going to add it up. The first day we are going to add it up. So now index of 3 will become, the index of 3 will become 1, 4, 4, 1, 4, 5, 1. Now we are going to start our loop from 2. We are going to add everything by adjusting the delay and forget values, and there may be chance that forget goes out of bound. Basically I plus delay and I plus forgot both can go out of bound, so we have to check particularly that j is less than equal to n. Only then we are going to calculate. And since they have told us to do modular arithmetic, I mean wrap up our answer to 10⁹ plus 7, we are going modulo, right? And here comes the important part. As we know, people are going to forget the things, so only last forgot days, the last particular forgot days are going to determine the sum, right? Because uh, the day before everyone has forgotten what was the secret. As this particular condition, after forgot days, they are going to forget what they know, right? So last forgot day are going to add up in answer. So we are just calculating the sum of the last forget elements, right? And we are just simply returning the answer. So the space complexity is order of n, and the time complexity is going towards n square. Here is the tabulation method. This is the order of n method, in which what we are going to do, we are doing the same, but for all the day we are maintaining a variable known as current ser or current running, or whatever you think appropriate to name your variable. But we are checking if I minus delay is greater than 0, I minus delay is greater than 0 at particular day. If yes, so we can surely infer that there are some people who know the secret at I minus delay day will contribute to this particular index, right? This as I told, I plus delay, after I plus delay we are going to add the value of no day of I. This is the same condition, but we are checking the backward. If that exists, we are going to take and add it to our ser variable. And we also have to check after forget days, they are going to forget whatever they know. So we have to subtract the knows of I minus forget, since they have lost the memory of whatever they know, that particular secret. So what we are going to do is, we are checking at that particular day previous which day are going to contribute in my ser, right? And from what particular day I have to remove the values, since we are going to forget the things after this particular amount. So after we calculate this ser of the current day, we are just assigning to it that knows of I. and again we are checking the for the last forget this, since these only are going to contribute in our answer. As we can see, we are not using two nested loops. It is simple order of n. It is simple of order of n, and the time complexity remains. The space complexity remains as it is. This is it for today. Thank you, everyone. I hope you are able to grasp the thing what I am talking about. Right? Thank you, everyone.